So like I said, today we're going to start with chapter 1. Some of your summer homework covers some topics from chapter 1. And so some of them we're just going to solely talk about on the summer packet. We're going to start with 1.5 as far as me giving you some instruction and homework assignments with, okay? So what we're going to do today is we're going to break up section 1.5 into today into tomorrow. So today we're going to take notes on half of 1.5 and then the rest of the class ask questions about the summer homework. Tomorrow we're going to talk about the second half of 1.5 and then use the last part of the class period to take our quiz, okay? So we're just going to talk about a few things. If you do have your graphing calculator, you can get it out because I'm going to show you one thing on it. Okay. The first thing we need to talk about is domain and range. Domain and range is one of the most important things that we're going to talk about today. Morgan and Josie. Okay, so domain. Who can give me a rundown on what domain is?
X values.
Okay. Anyone want to elaborate on that? Okay, I like that. Okay, the domain is what we input into our function, okay? All of the x values that make sense for our equation, okay? What about range?
The Y.
Okay, these are all the y values that make sense for our equation. We could also describe them as the set of outputs. Okay, domain, all the inputs, range, all the outputs. Okay, now when we look on a graph, okay, domain is everywhere we have x values. The range anywhere we have y values, okay? So here is a graph. Can everyone see that? Okay, it's just a piece, right? And so I want to describe the domain, okay? Where do we have x values? Okay, so here's the x-axis. Where do we have x values? From where to where? Okay, greater than -1, but less than 5, okay? So x is between -1 and 5. Okay, what about, this is an open circle, this is a closed circle. How does that affect our notation? We include -1 because there's an actual point there. We do not include 5 because there's not a point there. Right. Okay, let's talk about our range. Where do our y values stretch from? Okay, our lowest point is at -3, and our highest point is here at 3, right? So y, y stretches from -3 to 3. Does it include -3?
Yes.
Does it include 3?
Yes.
Okay. Now, I am going to show you a new way of notating domain and range. Okay? We are not going to use the alligator symbols anymore. Okay? It takes up a lot of room. Instead, we're going to use what's called interval notation. Okay? Interval notation, we're going to use either a bracket or a parentheses. So a bracket means that that value is included. So if you were going to put a line under your inequality sign, then you would use a bracket. Okay? If your value is not included in the domain and range, meaning you would put just the alligator symbol with no line under it, then you would use a parentheses. Okay, so we are going to describe the domain and range with our new notation. Okay, so our domain was x is greater than or equal to -1 but less than 5. Okay, so what this is going to look like, it's going to look a lot like a coordinate, but it's not a coordinate, okay, because we're describing the domain or the range. So our domain goes from -1 to 5. So I'm going to write -1, comma 5. Since we include -1, we're going to put a bracket. Since we don't include 5, we're going to put a parentheses. Okay. Our range stretches from -3 to 3. So we're going to write -3, comma 3. We include -3, so it gets a bracket. We include 3, so it gets a bracket. Questions? It's easier to write, takes up less room. The biggest thing that you're going to have to remember is when do I put a parentheses, when do I put a bracket? Okay, that's what you're going to have to remember. Okay. Let's look at another example. Okay, I have this graph. The domain. Where do we have x values? Not quite everywhere.
Oh, yeah.
Because we don't have anything here, right? So we have things below -1 and we have things above +1. Do you agree? Okay. These arrows mean it goes on forever. Okay. Well, we have to write this as an interval, and so we're going to have to use infinity and negative infinity. Okay, so I'm going to start over here. So over here, this goes from 1, x is 1, and it keeps on going in the positive direction. Do you agree? So we're going to write that interval as 1 to infinity. Do we include 1? Yes. Okay. Now, infinity is not actually a number, so infinity is always going to have a parentheses because we can't include a value that's not, we can't include this symbol. All right. Okay. So knowing that, how would we describe this piece? What would this interval be? We have everything from okay, -1 to negative infinity. I'm going to write it in order as negative infinity to -1. If you write -1 to negative infinity, I won't count you wrong. It just looks nicer this way. Okay. -1, bracket or parentheses? Bracket, because we have a value there. We can include it. What about negative infinity? Parentheses. Okay. Anytime you have more than one interval, you can connect them with a union symbol. Okay, so that's just saying these two intervals union together to make our domain. Let's talk about our range. Where do we have y values? Okay, so I'm going to just look along, like up and down the y-axis. Where do we have y values? Okay, they start at 0 and get bigger, right? So how would I write that as an interval? 0, comma, infinity. Do we include 0? Yes. And infinity always gets a parentheses. Questions? Okay, you'll get to practice this notation tonight. Okay. Hooray, that's right. Okay. Am I a function? How do we know if something is a function? This is something that I think was in your summer packet. How do we know if something is if a graph is a function? We have a test.
F of x.
Okay, f of x is how we notate it. But if we're looking at the graph, we have a test. Yes. We can't repeat the same x value. Do you remember what the test is called?
Test.
Yeah. Okay.
Oh. Yeah, Mr. doesn't like that, whatever it's called.
He doesn't?
No, he doesn't like names like that.
Okay. So we can't repeat any x values. We cannot have two coordinates that have the same x value. So every y value needs a unique x value.
The vertical line says.
Yes.
He did like that.
So when we are looking at a graph, we have the vertical line test, because if we draw a vertical line and we have 2 points on that vertical line, that means that those 2 points have the same x value, which means it's not a function. Okay? So, is this graph a function?
No.
No, our vertical line hits it more than once. Is this graph a function?
Yes.
Yes. Is this graph a function? Yes. Okay? Because anywhere we would draw the vertical line, we would only hit it once. It's okay if there's a space where it doesn't hit it at all. It can just hit at most one time. Okay? Everyone remembering that all right? Okay. Like I said, a lot of this is review, so we're going to kind of just boogie on through. Okay? Finding zeros. What does it mean when I say find a zero?
Intercepts.
What kind?
X and Y.
Well, we're going to stick specifically with x-intercepts. Why would it be called finding zeros? Why would finding an x-intercept be considered a zero? How do those two connect? Okay, yes, that your example was specifically for a line, but yes, you're on the right track. Okay, if we are talking about any sort of graph, okay, what is the y value at those 3 spots where we hit the x-axis? 0. Okay, that is what that's why we call it finding zeros. Okay, so if we're going to do this algebraically, okay, if I give you an equation, how do we find, I should probably say, I forgot my f of x equals, I apologize. Okay, how am I going to find the zeros algebraically? Okay, graphically we said it means what? What was here? What is 0?
The Y.
The y values are 0 when we hit the x-axis. So if we were given an equation, what should we do?
Solve. Factor.
Before we do any of that,
0.
okay, zeros, we're finding zeros. We should do something with 0. Our y value, or our f of x value, needs to be 0. Okay, now from here, okay, since this is a trinomial, what should we do? We should factor. Okay? Now, I know that Mr. Griebel, he has a Griebel way of factoring. I don't know the Griebel way of factoring, so if you had him last year and you know the Griebel way of factoring, go with it. Okay? to get a 3x squared, what am I going to need here and here? These two need to multiply to make 3x squared. So we need a 3x and a 1x, right? Now we need something here and here to multiply to negative 16. Okay, so if we do this, 4 and 4 multiply together to be 16, correct? What is 3x times 4? 12x, and what's negative 4 times x? Negative 4x. Does that get us the 22x? No, let's try again. Okay, good try. I would have tried it too. Didn't work out for us. That's why we use pencil, right? What do you want to try instead? What else multiplies to 16? 8 and 2. What's 3x times 8? 24x. What's negative 2 times x? Negative 2x. Does that get us to our 22?
Yes.
Okay. So now I factored. How do I find the 0? What do I do with those factors? Okay. Remember the zero product property. If we have a product, a multiplication, that equals 0, one of them has to be 0. So either 3x minus 2 is 0 or x plus 8 is 0. So this means x is negative 8 and this means x is 2/3. Okay, now remember, we're talking about intercepts on a graph. Okay. If I specifically ask you for an x-intercept, okay, here I asked you for the zeros, and that is fine. But if I ask you to label an intercept, I better see a coordinate. Okay, so if I ask for the x-intercepts, how would I write this? This intercept. 2/3 0. And this I would write negative 8, 0. Okay, so if I ask for intercepts specifically, those should be coordinates. If I ask for zeros, you can move them as is. All right, who wants to play with their calculator? Okay, if you have your graphing calculator, thought there would be a little bit more excitement there. If you have your graphing calculator, we are going to do this same problem, but on our calculator, okay? So, here's our calculator. Okay. Y equals, you can press it, and you can type in your equation. So we have 3. The x button is right here by alpha. 3x squared, here's squared, plus 22x, right? Plus 22, here's the x button, minus 16. If you hit graph, sorry, let me get mine back to normal. Don't get my window's off. There we go. If you press graph, you should get this. We got it?
How'd you do the first part?
3x squared. So 3. Here's x.
And then
And then say plus. You just type
you
in
just type
plus.
it in there.
Okay. So then what we can do is you can go to, does everyone have a graph? Okay, go with me to, okay, you can go to second, calculate, and we want to find a 0, And so that you can either arrow down or you can just press 2 to find 0. And it's going to ask you for a left bound. So you can toggle along your curve. Where am I? Okay, so you see how there's a little flashy dot? Okay, so it's asking for a left bound. So I want to go to the left of where it's intersecting the x-axis and hit enter. It's asking for a right bound, so I'm going to go to the right side of where it's crossing the x-axis and hit enter. And then it's going to ask you for a guess. And so you're going to say, yeah, enter, I want you to guess. And it's going to give you that 0. Okay, so here are the keys that I pressed. So second trace gets you to the calculate menu, and selecting zeros is how we got there. Okay, this is not something that you're going to have to do on a test. This is me just showing you how to use your calculator since you have it. Okay.
What did you do? Does it say negative?
Negative 8.
Mine says 0.667.
You might have like hit the over button with the trace. Okay. All right. So there's that. The instructions will be on my notes if you want to go back and play with it more. Like if you don't have your calculator and you get it tonight and you want to play with it, these will be online that you can go and play around with it. Okay. Okay. Last topic. I'm going to ask you to identify intervals of increasing and decreasing. Okay, how do we read words on a piece of paper? From left to right. We are going to read our graphs from left to right. Okay, our graphs are set up from negative to positive when we look at them left to right. Okay, so I'm asking you to take a graph and tell me where it is increasing or decreasing or remaining constant, right? We have a third option. If a function is increasing from left to right, what's it going to look like? It's going to be going up, right? If it's decreasing, then it's going to be going down, okay? So, our increasing intervals, we're just going to say that this graph stops here and here. We're going to pretend that it doesn't keep going, okay? So where are we increasing? From where to where? X is here at -3, and it stops increasing at
0.
At 0, okay? Now, anytime I ask you for increasing and decreasing, we're looking at the domain, okay? We're looking at the x values in which it is increasing or decreasing. So from x is -3 to 0, we are increasing. So in interval notation, we're going to say from -3 to 0. Since it is switching directions at those places, we are going to not include those values because at -3 and at x is 0, it's not increasing or decreasing. Do you agree? It's switching directions, so I feel like we shouldn't include it. Okay? What is the second interval in which this piece of graph is increasing? Okay, x is 3 to 5. And since it's not increasing or decreasing where we're changing places, we're just going to leave it as an open interval. Okay, and since we have two intervals to squish together, I'm going to put a U in between. Decreasing intervals. Where is this function decreasing? Zero to 3. Good. Where else? -5 to -3. Okay, so from -5 to -3, we're decreasing. From 0 to 3, we're decreasing. Okay, there are two. All right, so here is your homework. Okay, it is not very long. You have some odd problems. Anytime I give you an odd problem from the book, what do I expect you to do? Check your answers. I give you odd problems so that you can check your answers. Please do that. Okay? Those of you who don't have who didn't check out a textbook, I will scan in the problems and the odd answers from the back of the book so you have the same access. Okay? Now, remember yesterday when I said I want you to evaluate yourself after every homework assignment that we do? Okay? Along with your homework, I'm asking you to fill out a 1-question little survey before you come to class so I know how you feel about the homework. So, if I can show you very quickly, when you go to my website, here's my website, under Precalculus, everything that you want right now is under Chapter 1. So under Chapter 1, it says 1.5 homework evaluation. Okay, since we did 1.5 today, that's the homework evaluation. Now, I have not set up the survey yet, but you haven't done your homework yet, so that's okay. So if you come here this afternoon, you can click on that, and it'll ask you, how did you feel about today's homework? And you're going to rate yourself 1, 2, 3, or 4. If you do not fill out the survey, then I'm assuming that you didn't do your homework, and I'm going to mark that down. If you don't do your homework enough times, we're going to have a conversation. Okay? It is not a very long assignment. I need you to do this, and I need you to answer my 1 question before we start class tomorrow. Okay? All right, so if you need to continue writing down the homework, there it is. Go ahead and get